In this video, I will demonstrate how to solve the exercise Creating a Cyber World of the course Cybersecurity Essentials from Cisco. So, in this exercise, we'll have to configure the FTP server, web, email, DNS, NTP and AAA server. But before I start, subscribe to the channel for more videos like this, hit the like button to like this video, and if you have any questions, write them on the comments. So let's start doing the exercise. First, we have to configure the FTP server. So we go to the Metropolis Bank headquarters network, and in this network we'll find three servers: the FTP web server, email DNS server and NTP AAA server. We have to click the FTP web server to configure. We go to Services and choose FTP here. To activate the service, we press On. And now, to allow users to access the FTP server, we have to create the accounts. In the user setup, we have username and password. In the username, we are going to create the account for Bob, so we write Bob, and the password will be Cisco 123. The permissions will be write, read, delete, rename and list, so all the permissions, and press add to add the user. Another user will be Mary with the password Cisco 123, all the permissions, and add, and the last will be Mike. Mike Cisco 123, all the permissions, and add. So we have now three users with password and permissions. Now we are going to configure the HTTP service. So we choose this service, HTTP, and to activate it, we press on, and also to HTTPS on. Now the HTTP service is on. Let's verify if the HTTP service is working. We close the window. Let's open the PC from Sally. We go to Desktop, press Web Browser, and we'll write a website like www.cisco.corp and press Go. Nothing happened, but it was supposed to do this because we haven't configured the DNS server. If we tried using the IP, so 10.44.1.254 and go, we can open the Cisco Corp page. So accessing the web page via the IP is working, but via the domain name is not working. Now let's configure the DNS server. We open the DNS server. This is one, email/DNS. Open the services. Choose DNS. Where is DNS? Here. And to activate the service, choose on. Now we have to add the resource records. We have to create an A record, so the name will be email.cisco.corp, and the address will be 10.44.1.253, and add. This is for the email server. We are going to create a second one for the web, so will be www.cisco.corp, also an A record. The address will be 10.44.1.254 and head. Now we have two records, one for the email server with its IP, another for the web with this IP. Let's verify if the DNS now is working. Close the window, go back to Celis PC, open the web browser, and let's try www.cisco.corp. Press go. Now we can see the web page using the domain name. If we try to see the traffic, let's push this and press go. When I open the page, we can see the triangles, the green triangles lighting up like this. So the communication is going from the Celis PC to the switch, the other switch to the DNS server, and locating the web server. So the communication is working. Now let's configure email server. We go to email server and choose the service email, and we'll activate the SMP service, turning on, and the POP3 service, turning on. The domain name will be cisco.corp, and press set. And now we are going to create some user accounts for the email, like for Phil. The password will be Cisco123, and press the plus to add the account. For Sally, add. For Bob, also the same password. Dave, with Mary, Tim, and Mike. In the real world, you should not create passwords so simple. Should be complicated and never the same to other users. We can check the passwords and username by selecting the name. Now, with the accounts created, let's configure the email clients in the PCs. So let's open the Celis PC. Let's choose email, and let's configure the email. The name will be Sally. The email address sally@cisco.corp. The incoming email is email.cisco.corp, and the outgoing mail server also email.cisco.corp. The username is Sally, and the password Cisco123, and save. Now we are going to configure for the Bob. Open the PC from Bob, go to desktop, email, and configure with Bob's information, so name Bob, email address bob@cisco.corp, incoming mail server and outgoing mail server the same, username Bob, and the password Cisco123, and save. Now we have to configure the NTP server. So the network time protocol is a networking protocol for clock synchronization between computers and servers on a network. We open the NTP/AAA server. We go to services and choose the service NTP. To activate, select on, and the server is activated. But to secure the NTP service, we have to click Enable the authentication. We'll select the key 1, and the password will be Cisco123. Now is activated and secure. In this server, we also have to configure the AAA service. So select the AAA, and to activate it, select on the service. To configure this service, in the network configuration, in the client name, we are going to write HQ router, The client IP will be 10.44.1.1. The secret will be Cisco 123. The server type, we leave it like this and press add. Now we have a client for this service. Also, on the user setup, we have to add a user. So, in the username, we write admin, and the password will be Cisco123, and press add. Now we have a user to access this service. And the laboratory exercise is completed. Everything we had to do is done. But let's try some connections. Let's try to send an email from Sally to Bob. So we press the Sally's computer. We go to email. You press compose. And to will be Bob at cisco.corp. The subject will be hello, just to say hello, and we press send. On the bottom we can see all the information sent to Bob with the subject to this server, this IP, and the email will send with success. Let's close this client and open the client on Bob's computer. Let's choose email and press receive. On the receive we have an email from Sally saying hello, and this is the email received with success. So the email server is working fine, the configuration on Sally's and Bob's computer is fine, so the communication on the network is working. The email go from Sally to the server to Bob's. So everything was done correctly. If you like this video, subscribe to the channel to see more exercises and demonstration about Cisco courses. Hit the like button on this video and leave a comment if you have any question about this course or about what we've done on Packet Tracer. And I will see you on the next video. In this video, I'll demonstrate how to do the lab exercise Communicating in a Cyber World from the course Cybersecurity Essentials from Cisco. In this exercise, we'll send an email between users, upload and download files using FTP, remote access an enterprise router using Telnet and using SSH. But before I start, subscribe to the channel for more videos like this, hit the like button to like this video, and if you have any questions, write them on the comments. So let's start doing the exercise. First, we have to send an email between users. So let's open the Gotham Healthcare branch network and open the My PC. Go to desktop, open email, and we'll send an email to Sally. So Sally at cisco.corp with a subject urgent saying call me, and press send. And on the bottom we can see the email was sent with success. Now let's check the Sally's client email. So we close the window, go back, we go to the network Metropolis Bank, go to Sally's computer, go to desktop, email, and receive. And we got the email from Mike saying urgent, call me. So the communication via email between networks, different networks, is working. We sent an email from this network to the internet and to this network, and the communication is working. Now let's demonstrate using FTP. But first, we open the Cyber Criminals sniffer. This is a packet sniffer to capture traffic. Open this tab GUI and select port 1. When the traffic starts flowing, this area will start to be populated with packets information. Let's start using the FTP. We close this, go to this network, Healthcare at Home, and open the PC from Mary that is working from home. Open the desktop, select Command Prompt, and we'll connect to the FTP server on the Metropolis Bank network. So we'll use the command FTP space in the IP from that network, that is 209.165.201 and .3. Press enter, and it's trying to connect, and is connected to the network, and is asking for the username, that is Mary, so write Mary, and the password will be Cisco123. Press enter, and we are connected with these credentials. Now let's upload the file. Now let's check the files on the server, right there, and we can see the files on the server. Now let's upload the file. So we write put in the file name new clients.txt, and the file was transferred. Now let's check if the file is there, right there, and this is the file. The file we just uploaded now is in the server. Let's analyze the FTP traffic. So close the window, go to the criminals sniffer, and this is more information. So all the packets that the sniffer capture, and let's try to find the first FTP, this one. Let's expand this, and we can see the IP in here. On the bottom you have the FTP command user Mary. Let's find the second FTP, this one. On the bottom, and the path is Cisco123. So the packet sniffer captured the login and password and IP from the server, so I have all the information I need to access that server with these credentials, because the access was not secure. Now let's try to telnet the server. Let's open Healthcare at Home. We go to Dave's PC, open the desktop, open Command Prompt, and let's try to ping the enterprise server. So write ping and the IP from the server 209.165.201.2. Press enter, and it's pinging, so we can reach the server from this computer. Now let's telnet to the computer, so we write telnet and the IP 209.165.201.2. Press enter. It's asking for the username. The username is admin. Enter, and the password is Cisco123. Press enter, and we are on server using the admin account. Let's write a command like show users. Okay. We can see that this user is connected, so telnet is working. Now let's try to SSH to the router. Let's go back, open the Gotham Healthcare branch network, go to Teams computer, go to desktop, Command Prompt, and try to ping the router. Ping in the IP 209.165.201.2. Enter. We can ping the router. Let's try SSH. So SSH-L, and the username will be admin, the IP 209.165.201.2. Enter. Is asking for the password because the username admin is here. So Cisco 123, enter, and we have access. Now let's write a command like show users. We can see the user accessing via telnet and the new user accessing via SSH. To secure the access, we'll enter the global configuration mode. So you write the command configure terminal, enter. We can see config, so we are in config mode, and enter the command enable secret Cisco, and the secret is enabled, the password is enabled. And this is everything you had to do on this exercise, so everything is fine. But before ending, let's check the cybercriminals sniffer to see the packets from telnet, so we can see that's a lot more information. We select telnet, let's expand this. So what information can we see? We have data here, let's select another. So we have an A, a D, an M, an I, N. So admin, the other one will be space, and C, I, I'll bet will be an S. So this is the password. So we are sniffing packets, and via telnet we can get the traffic information saying admin and Cisco 123. So the username and password and the IP is here. So all the information we need to access the router with the admin account. So this is not secure. Telnet is not secure because it's not encrypted, but with SSH the connection to the router will be encrypted, so it's safer. So this is everything. If you like this video, subscribe to the channel to see more exercises from Cisco courses and demonstrations with Packet Tracer. If you learned something with this video, hit the like button and write in the comments what Cisco course are you taking, or if you have any question about Packet Tracer. And I will see you on the next video. In this video, I will demonstrate how to do the laboratory exercise of configuring a network with WEP, another network with WPA2 PSK, and another network with WPA2 radius of the Cisco course of Cybersecurity Essentials. But before starting, subscribe to the channel not to miss more videos about Packet Tracer and courses of Cisco. Hit the like button if this video helped you, and write in the comments if you are taking the course of Cybersecurity Essentials of Cisco. So let's start the exercise. First, we have to open the Healthcare Home network, and we are going to open the PC0, that is a desktop connected directly to the router, so we can configure the router. You click the PC0, open the desktop, the command prompt, and write the command ipconfig, and we can see the IP from the computer, the subnet mask, and the default gateway IP. That is what we need to access the router. So let's open the web browser. Open web browser and go to 10.44.3.1. Press go. He asks for the credentials. Will be the username admin and the password admin. Press OK. And we have access to the router, so we can configure the wireless access. Now we go to the wireless tab. We are going to change the network name SSID from default Wi-Fi to home. We are leaving other configurations like this and press enable to start broadcasting the SSID. Now we go to the bottom of the page and press Save Settings. The configurations are saved now. Now we go to the option Wireless Security to configure the wireless access. The security mode, we are going to change it for WEP. It will show other options to configure. Keep the encryption mode as is, and we'll create a key with 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 as key 1. Go to the bottom of the page and press Save Settings to save the configurations. And now we have access key to access the wireless router. Now let's configure the clients. We can close the PC 0 and we are going to open the PC Dave. It's a laptop. Open Desktop, go to PC Wireless, open the tab Connect, click Refresh. It will show a network called Home. Select that network and press Connect. With the security as WEP, we are going to enter the key, the WEP key 1 that we configure on the router. That is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 and press Connect. You can see that a connection was made between the laptop and the router. So the connection was successful. Now let's do the same for Mary's computer. You can close Dave's computer and open the laptop for Mary. You can see there's no connection between the computer and the router, neither a physical connection, neither a wireless one. So open Desktop on the Mary's computer, go to PC Wireless, select Connect tab, press Refresh, select the Home network, press Connect, and write the WEP key 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And when we press Connect, the connection will be made wirelessly. So we can see there's no connection. We press Connect and a wireless connection was made between the computer and the wireless router. So all the clients in this network are configured and have access to the wireless router, so they can connect to the internet. Let's close this computer. Now let's configure the network from Gotham Healthcare branch. We press this network. This network will be configured with WPA2 PSK. So let's set up the wireless SSID from the router. We select the PC1 that has a physical connection between the computer and the router. Go to Desktop, go to the command prompt, write ipconfig to see the IP from the default gateway, that is 10.44.2.1. We can close the command prompt, open the web browser, and write that IP from the default gateway, 10.44.2.1. Press go. The authentication username will be admin and the password admin. Press OK. And we have access to the wireless router. Now open the tab Wireless and change the network name SSID from default Wi-Fi to branch site. Also change the standard channel from channel 1 to channel 6, working at 2.437 GHz. And to start broadcasting the SSID, press Enable. With these configurations, go to the bottom of the page and press Save Settings to save the configurations we made. Now let's configure the wireless security, pressing the option Wireless Security on this tab. Select mode will be WPA2 Personal. Keep the encryption AES and add a passphrase with the name Cisco Secure. Go to the bottom of the page and press Save Settings. And with this wireless AP configured, let's connect the clients. Can close PC1 and let's configure these two computers. First, the desktop of team. Press the team computer. Open the desktop. Because the computer don't have a physical connection to the router, let's configure the PC wireless. So the wireless connection. Select the tab Connect. Press Refresh. It found two networks. Select the branch site, that is this router we configured, and press Connect. The security will be WPA2 personal, and the shared key is Cisco Secure. And we'll press Connect, and we can see we have a wireless connection between the computer and the router. Now let's close the team's computer and do the same to Mike's computer. Press the computer for Mike, go to desktop, PC wireless, connect, refresh, select the network you want, the branch site, press connect, maintain the security WPA2 personal and the shared key Cisco Secure. And we can see there's no connection between the Mike's computer and the router, and when I press connect, the wireless connection was done with success. So this network is done. Let's close Mike's computer, go back to the world, and finally let's configure the Metropolitan Bank headquarters network. This network will be configured with WPA2 radius, and let's start to set up the wireless SSID. So to configure the wireless router, you have to use Celis computer that has a physical connection to it. So open Celis computer, go to desktop, open the web browser, and write the IP of the wireless router, that is 10.44.1.251, and press go. The authentication username will be admin and the password admin. Press OK. Now we have access to the wireless router. Let's press the tab Wireless. Change the network name SSID to HQ, meaning headquarters. Change the standard channel to the channel 11 and enable SSID broadcast. Go to the bottom of the page and press Save Settings. The configuration is saved. Now let's configure the wireless security. Press the option Wireless Security. Security mode will be WPA2 Enterprise. Maintain the encryption as AES, and the radius server will be with the IP 10.44.1.252. And on the shared secret, write Cisco Secure. Now go to the bottom of the page and press Save Settings to save the configuration, and the wireless router is configured. Now let's configure the radius server. Close the Celis PC and open the NTP AAA server. Go to Services, open the service AAA, and configure the network configuration with the client name will be HQ. The client IP will be 10.44.1.251. Secret is Cisco Secure, and the server type will be Radius. Press Add to add this network configuration, and we've created another network configuration. Now let's add users. On the user setup area, write username Bob with a password secret ninja Bob, and press Add, and another user called Phil with a password Phil was here. Press Add, So we have two new users, Bob and Phil. We can close this server. And now let's connect the clients. First, open Bob's computer. That doesn't have a connection to the router, neither a physical or a wireless connection. Go to Desktop, PC Wireless, go to the tab Profiles, click New to create a new profile with a name Radius, press OK, press Advanced Setup for this profile, and the network name will be HQ, press Next, maintain to obtain network settings automatically with DHCP, press Next, security change it to WPA2 Enterprise, press Next, the authentication will be PAAP, login name will be Bob, password will be Secret Ninja Bob, and press Next and save. Now press Connect to connect to the network. We can see there's no connection, and when we press Connect to Network, it will try to connect the wireless card to the wireless AP. This can take a little bit, and you have successfully connected to the access point. So we have a connection from Bob's computer to the network router. Let's close the Bob's computer and do the same to Phil's computer. Let's try to see this area. So we have Phil's computer and the wireless router. In Phil's computer, open Desktop. The configuration is the same. PC Wireless, Profiles, New Profile, called Radius, Advanced Setup, network name HQ, Next, obtain network settings automatically, Next, security is WPA2 Enterprise, press Next, login name is Phil, and password will be Phil was here. Press Next. This is the profile settings. Press Save. And we can see there's no connection, neither physical or wireless. And when we press Connect to Network, it will start to try to connect. There it is. Phil's computer is connected to the wireless router via wireless. We can close Phil's computer, and the exercise is done. All configurations are done on the routers, on the server, and on the client's computers. But before we test the connections, subscribe to the channel not to miss more videos like this and more demonstration with Packet Tracer. Hit the like button if this video helped you, and write in the comments if you have any questions and if you are taking the Cisco Cybersecurity Essentials course. Now let's test a connection. We are going to open Bob's computer, go to command prompt and write ipconfig, and the IP on this computer is 10.44.1.3. So let's close Bob's computer and open Phil's computer. Open the command prompt on Phil's computer and let's try to ping Bob's computer. So we write ping and the Bob's computer IP, that is 10.44.1.3, and enter. And the ping was done with success. So we have communication working. Phil's computer is communicating with the wireless router, and the wireless router is communicating with Bob's computer. So the networking is working and the communication is working. That's everything for this exercise. Subscribe to the channel, hit the like button, and write in the comments if you have any questions about this exercise or Packet Tracer. And I will see you on the next video. In this video, I will demonstrate how to do the laboratory exercise configuring VPN transport mode of the course Cybersecurity Essentials from Cisco. In this exercise, we'll send an encrypted FTP traffic, then we'll configure a VPN client, and again send the FTP traffic but encrypted. But before start doing the exercise, subscribe to the channel if you want to see more videos about packet tracer, networking, and Cisco courses. Hit the like button if this video helped you, and leave a comment if you have any questions about packet tracer, this exercise, or networking. Now let's start doing the exercise. First, you need to open the Cybercriminals sniffer. Open the GUI. And here, if you have any information, press clear to clear because you want to see the network traffic this sniffer will get. Let's minimize this window. And now, open the network Metropolis Bank. Open the computer of Phil. Go to desktop. Open the command prompt. And write the command ipconfig. And here we can see the information about the network on Phil's computer, the IP, the subnet mask, the gateway. And now we'll connect to FTP server using the FTP connection. So write the command FTP and the server IP. So the Gotham Hellcat branch, the FTP server, and this is the IP. Write FTP and the IP 209.165.201.20. Press enter. It's connecting. Now it's asking for the username. That is Cisco. And the password will be public key. We are connected to the FTP server. And now we'll try to send a file. Write put and the name of the file. That is public info.txt and send. The file was transferred. Now let's check the sniffer. And now we can see that we have new information on the buffer size. When we press it, we can see the IP, and on the bottom we can see the information of the FTP connection. Like the user is Cisco. On the next one, we can see the password is public key, and the other ones we can see like the file we send. So because FTP is not secure, is not encrypted, all the information is in clear text. So with a sniffer we can view all the information. We have the IPs, we have the password, the login. So with this information we can access the FTP server, because the protocol FTP is not secure. Now let's configure a VPN for this user. Let's quit the server. Let's try to ping the server. So 209.165.201.19. Let's try ping it again. Okay, now everything is fine. Let's quit the command prompt and we'll open the VPN application and we'll configure this VPN. The group name will be VPN group. The group key will be 123. The server IP 209.165.201.19. Username Phil and password Cisco 123. And when we press connect, we'll connect to the VPN using these credentials. The VPN is connected, so we can press OK. Now we are connected with the VPN and we got this IP. Now let's try to send again a file. You go to the command prompt. Let's connect to the server FTP, and the IP of the server is 10.44.2.254, and we have a connection. The username will be Cisco and the password will be secret key, and we are logged in. Let's try to upload a file, so we write put in the name of the file private info.txt, press enter. This file was transferred and we can see it here. Now let's bring back the sniffer, and in these new packets we can see that we can't see the username or password because the network traffic is encrypted. We are still using the FTP that is not secure, but because we are using a VPN, all the network traffic is encrypted. So the network connection is secure using a VPN. And this is why it's better to use a VPN to these connections, because the FTP protocol is not secure, but the connection via VPN is. So all the traffic will be encrypted. So if you like this video, subscribe to the channel for more videos about packet tracer, networking and Cisco courses. Hit the like button if this video helped you, and leave a comment if you have any question about packet tracer, networking or Cisco courses. And I will see you on the next video. In this video, I will demonstrate how to do the laboratory exercise configuring VPN tunnel mode of the Cybersecurity Essentials course from Cisco. In this exercise, we'll send unencrypted FTP traffic, then securing the VPN tunnel between two networks, and then sending encrypted FTP traffic. But before we start the exercise, subscribe to the channel if you want to see more videos about packet tracer, networking and Cisco courses. If this video is helpful, hit the like button and leave a comment if you have any question about packet tracer, networking or Cisco courses. Now let's start doing the exercise. First, we are going to open the Cybercriminals sniffer. Open the GUI. If you have any information here, you should click clear to clear all the information, because you are sniffing the network and you want to see the newer information. Now let's minimize this window. Now we are going to connect to the FTP backup server, so go to the Network Metropolis Bank headquarters. Open the computer of Phil. Go to desktop and open the command prompt. Write the command ipconfig to see the network configurations on this computer. You can see the IP, the subnet mask and the default gateway. Now let's connect to the file backup server at Gotham Healthcare branch. We can see that the IP of that server is 10.44.2.254. So write the command ftp space 10.44.2.254 and enter. We have a connection to the FTP server. Username write Cisco and the password Cisco. And you are logged in to the FTP server. Now go back to the sniffer and we can see two FTP entries on the buffer size. Click it, and on this packet you can see the IP, source and destination, and on the bottom you can see the username is Cisco, and when you go to the other packet, on the bottom you can see the password is Cisco. So the sniffer got all the information you need to access the server. You got the IP and the credentials, because using the FTP protocol is not secure, because all the communication done on the network is in clear text. And that's what we are going to resolve in this exercise. So let's minimize the cyber sniffer, and now we'll configure a VPN tunnel between two networks. So we can close the computer of Phil and open the HQ router. On the router, open the CLI, can press enter, so we can enter commands. And now we need some code. This configuration, that are the commands to configure the router. Copy these commands and paste on the CLI. The router will execute every command, and now the router is configured with a VPN tunnel between two networks. The configuration on the other router of the other network is already configured for this exercise, so the routers on the two networks are configured and are connected with a VPN tunnel. Now let's try to send traffic again with FTP, but with the VPN tunnel, so the traffic will be encrypted. Open the computer of Sally that is in this network. Go to desktop, go to command prompt. Let's check the IP configuration. Write the command ipconfig. You can see the configuration of this computer. And let's connect to the file backup server at Gotham Healthcare branch. So enter the command FTP and the IP of that server. That is 10.44.2.254. Because we are using the VPN for the first time, this could fail. Okay, so let's try to ping the server. Write ping 10.44.2.254. Let's see the ping. We'll try to ping it 4 times. It failed. Request timeout. Let's see, it failed again. Okay, let's wait. Okay, it pinged the server with success, so let's try ping it again. And now it's working fine. So let's try to connect the FTP again to the same FTP server. So we are connected to the FTP with success. The username to connect to the FTP server is Cisco. Right, Cisco, and the password is Cisco. And we are logged in. Let's try to upload a file. So write put, and the file name will be ftp upload.txt. Press enter, and the file was uploaded with success. If you write there, the file is here. So the connection in the upload to the FTP server was done with success. Let's inspect the cybercriminal sniffer. So let's see the buffer size, and there's no new entries. Why? There's no new entries here because we are using a VPN tunnel between the two networks, so all the communication is encrypted. And this packet sniffer could not disencrypt the packets. It could not view any of the information after the VPN tunnel was configured between the two networks. So, connecting the two networks with a VPN made all the communication and connections encrypted and secure. Even using a non-secure protocol like FTP, the connection was encrypted and became secure. And that's everything for this exercise. Now, if you want to see more videos about packet tracer, networking, and Cisco courses, subscribe to the channel. If this video was helpful to you, hit that like button. And if you have any questions about packet tracer, networking, or Cisco courses, write on the comments. And I will see you on the next video. In this video, I will demonstrate how to solve the laboratory exercise Router and Switch Redundancy of the course Cybersecurity Essentials from Cisco. In this exercise, we'll observe a network failover with redundant routers and another failover with redundant switches. But before starting the demonstration, subscribe to the channel to see more videos about packet tracer, networking and Cisco courses. Hit the like button if this video helped you, and write in the comments if you have any question about packet tracer, this exercise or Cisco courses. Now let's start doing the exercise. We are going to open the Metropolis Bank network. Open the Fields computer. Go to the desktop and open the command prompt. And now we are going to ping the external server that has the IP 209.165.201.10. So write the command ping and the IP 209.165.201.10 and enter and wait for the ping. The first ping didn't work. Let's wait, we'll try 4 times. Another request timeout. Okay, now the ping is okay. It failed 2 times because we are trying this for the first time, but should be okay right now. Now let's see the root of the communication. Write trace RT and the IP of the server, that is 209.165.201.10, and press enter. We can see all the devices the communication had to use to reach the server. If we get our table, we can see the IP 10.44.1.2 is the router 1. So this router. The second one is 10.45.2.2. That's not here, but it's probably this router. That is the gateway for the network. Then another IP, and finally our external server. So this device is probably the gateway to the network of this server. Now let's cause a network failover. Let's minimize. Now open the switch number 1. Go to CLI. And now we will stop this interface of this switch. So in the CLI, write enable, configure terminal, and choose interface gigabit Ethernet 0/2. Now we are in mode config of the interface and write shutdown. When we press enter, we'll shut down this interface number 2. So enter, and now it's red. So it's not working, this interface. And this interface connected the switch to the router. And because of this failover, the network needs to find another path. So go back to Fields computer. Let's see the network. Let's try to do the ping again to the same server. And it's working. Even with this failover, with this interface not working, it's working. And let's try to do a trace route to the same server. We have 4 devices. If we bring the table of the IPs, so the first one, 10.44.1.3, this IP, now this is the router number 2. So the connection went down here. The connection went from Fields computer to switch 1 to switch 2 to router number 2, because the interface that connects switch 1 to router 1 is not working. So the network found another path. Then the second device is 10.45.1.2. That's not on our table. That's again this router that is the gateway to the network. Now let's try redundancy of switches. Let's close this network. Let's go to the network Gotham Healthcare branch. So in this network we have only one router, but we have several switches. We have switch number 1, 2 and 3. and we'll test a failover on a switch. So open the computer of team that is connected to switch number 3, open the desktop, open the command prompt, and let's ping the external server. So ping and the IP 209.165.201.10 and hit enter. Let's wait to the ping. The communication is happening. It's trying to ping the server and everything is fine. We can ping the server on this network, but in this case we'll cause a failover while we are communicating. So we write again ping, but with the parameter -t to have a constant ping. So we are pinging the server from Teams computer. And now let's deactivate this interface on switch number 3. So open switch number 3, go to CLI, enter the command enable, enter configure terminal, write interface gigabit Ethernet 0/2, because interface gigabit Ethernet is this one that connects switch number 3 and switch number 1. So press enter and write shut down. When we'll press enter, the interface will be off. So enter and turn red. Now let's open the ping. Okay, you cannot ping the server anymore, so the network is trying to find another way, another path on this network, and this could take between 30 seconds to 1 minute. So let's wait. It's trying to find some other path. We have this path through switch number 2, so you'll try to activate this interface on switch number 2. So let's wait a little bit. This is in real time. It continues to ping or trying to ping the server. Come on, network. Okay, now it's green, so the ping starts working. Okay, it's fine right now. So the network has redundancy on switches because we have this failover between the interface of switch number 3 and switch number 1. The network tried to find another path, in this case through switch number 2 and then to switch number 1 and to the router and on the internet. So in this exercise we'll demonstrate the importance of having redundancy on routers and redundancy with switches, because problems can happen, devices can fail, but the network will try to find another path to work. And this is everything. The exercise is completed. If you want to see more videos about packet tracer, networking or Cisco courses, subscribe to the channel. If this video helps you, hit the like button and write in the comments if you have any questions about packet tracer, networking or Cisco courses. And I will see you on the next video. In this video, I'll demonstrate how to solve the laboratory exercise Router and Switch Resilience of the course Cybersecurity Essentials from Cisco, and will hardening the iOS configuration and activating the Cisco IOS Resilience configuration feature. But before start doing the exercise, subscribe to the channel not to miss more videos about packet tracer, networking and Cisco courses. Hit the like button if this video helped you, and comment if you have any questions about packet tracer and this exercise. Let's start doing the exercise. You should open the network Metropolis Bank, open the computer of Sally, open the desktop and the command prompt, and now we'll remote connect to the router. This is the router with the IP 10.44.1.1. So we'll connect via SSH. So write the command SSH -L, the username is admin, and the IP 10.44.1.1, enter. It asks for the password, that is Cisco 12345, enter, and we are on the router. We can see that we didn't got any warning, any message when we entered the router. And we should have a warning message preventing unauthorized users from accessing the router. So let's do that. Let's create a legal notification message on the router. Enter the command enable. The password is class. Now enter configuration mode. Right. Configure terminal. We are on config mode. Now you should get the message your teacher gave you. This is a command for a banner of MOTD, so message of the day. Copy the message and paste it. This will enter all the lines of the message for the message of the day. Let's check if this worked. So end the config mode with the command end log out. So we are logged out of the router, we are on the computer. Let's again try to SSH to the router with the password Cisco 12345, and now we have a warning message when we access this router. A warning saying unauthorized access to this device is prohibited, and the rest of the legal information. So this was the first step to configure this router. Now let's enforce password security on the router. So right, enable the password class, enter the config mode with the command configure terminal. We are on config mode, and now we'll encrypt plain text passwords in running config. So write the command service password dash encryption. And to enforce any new configured passwords to have a minimum of 10 characters, write the command security passwords min dash length space 10. Now the passwords are encrypted and they need to have at least 10 characters. So the router is more secure now. And now the next part is activating the Cisco IOS resilient configuration feature. Let's start to check the iOS image, so exit config mode and write dir flash. You can see the first file is a bin file. This is the current iOS image. So we'll enter the configure mode. So configure terminal. And first we'll secure the boot image. This will activate iOS image resilience and prevent the iOS file from both showing in the directory output and prevents the deletion of the secure iOS file. So write the command secure space boot dash image and enter, and we got the message successfully secured running image. So our iOS image of the router is secured. Now let's store a secure copy of the running configuration to prevent the deletion of the secured configuration file. So write the command secure space boot dash config and enter, and we got the message successfully secured config archive. That is this file .ar file. Let's see if these configurations worked. So let's exit config mode, write exit, enter, and dir flash. We no longer see the .bin image, the iOS image we saw earlier, but the image exists. To view the status of the Cisco IOS image and configuration resilience, write the command show secure boot set and enter, and we can see that we have an iOS image resilience, and this is the file, .bin file, and we have an iOS configuration resilience .ar file. So both the iOS image and the iOS configuration is secure on this router. And this is everything you had to do to complete this exercise. Now subscribe to the channel if you want to see more videos about Packet Tracer, networking and Cisco courses. Hit the like button if this video helped you, and write in the comments if you have any questions about Packet Tracer, about this exercise, networking or Cisco courses. And I will see you on the next video. In this video, I'll demonstrate how to do the laboratory exercise server firewalls and router ACLs of the Cybersecurity Essentials of Cisco. And on this exercise, we'll connect to a web server with HTTP and HTTPS, then configure to prevent unencrypted HTTP sessions, and finally access the firewall on the email server. But before starting, subscribe to the channel for more videos about Packet Tracer, networking and Cisco courses. Hit the like button if this video helped you, and leave a comment if you have any questions about this exercise, about Packet Tracer or Cisco courses. Now let's start doing the exercise. First, go to the Metropolis Bank headquarters network, open the computer of Sally. Now open the desktop and open the web browser. Now we'll open a website. Write the URL http://www.cisco.corp and press go to open the website. And we have opened the website, and click login page. Here we have a form to fill and submit. The problem we have with this website, it's using the HTTP protocol, so the information is not encrypted. All the information you fill, the name, the password, the security identifier you send to the web server, will not be encrypted, so any sniffer on the network or during the traffic until reaching the web server will not be encrypted. Everyone can see in plain text all this information you fill on the questionnaire. So they can sniff the packets and see all the information in plain text of this form. And this is a security problem. So now let's open the website again, but using the HTTP protocol. So we'll erase this and write HTTPS, and the rest is the same URL of the web page, and press go. We have opened the same web page. Go to login. Now using the HTTP protocol, that is unencrypted, a secure protocol, all the information you fill on the form will be encrypted. When you submit on the website, all the information you send to the server will be encrypted. So no sniffer can decrypt the information, and this is the problem we want to solve, only allowing on this network access to websites using the HTTPS protocol. And we are going to do this on the router. So close the Sally's computer and open the router of the network, this gateway. Now open the CLI, the command line interface. Press enter. It asks for the password to access the router. The password is Cisco. Press enter. Now we have access to the router. Click enable and then configure terminal. So write configure terminal. Now we are in config mode. Now we have access to the global configuration to the router, and we'll enter the commands to prevent unencrypted HTTP traffic from traveling through the router using ACLs, so access control lists. The first command, write access dash list space 101 space deny space TCP space any EQ and 80 and press enter. So this command will use this ACL and deny TCP traffic on the port 80, so the HTTP protocol. The web pages will open on the web browser. The second command is access dash list space 101 space permit space IP space any and enter. This command will add another rule to this ACL to permit any IP traffic. Now let's configure a specific interface of the router. So let's open just the name of the ports. Now we want this port gig 0/0. Let's open the router again, go to the CLI, and we'll choose that interface. So write interface gigabit Ethernet 0/0 and press enter. So now we're on config mode of this specific interface that connects the network to the router, and write the command IP space access dash group space 101 space in and enter. Now let's write end to exit the configuration mode, and let's try to use again the website on Sally's computer. So open the computer of Sally. Let's open the web browser and try to access the web page with the HTTP protocol. So write the URL http://www.cisco.corp and press go to open the page. It's taking a while now. Let's wait, and we'll get a request timeout. So we could not access this web page with this protocol. But if we try to open the page with the protocol HTTPS, let's try to open the page. It works. The router allows the traffic with the HTTPS, but not with HTTP. With this configuration on the router, no one on the network can access a website with an unencrypted session. So every communication and information on this website or any website will be encrypted. This is very important because the normal user doesn't know the difference between HTTP and HTTPS, doesn't know about security, encryption, and with this configuration on the router, we guarantee that all the communication is encrypted and secured. Now, finally, let's check the email server. So open the email server, open the desktop, and open Firewall. In here we can do the same what we did for the router, using ACLs to control and add rules to the network configuration of the email, like we did on the router, but here we have a graphic interface. So in this firewall, we turn on the firewall, we choose the interface. In this case, there's only one interface, the FA0, so Fast Ethernet 0. We choose the action, allow or deny. We choose the protocol. We have several protocols, choose TCP, and configure IPs, ports, and then add these rules. So we are creating ACLs, access control lists, for the email server, so the email communication on this network. This is the importance of ACLs in the network. You can configure an ACL in the CLI or in a GUI, a graphical user interface. And this is everything you have to do to this exercise. Now, subscribe to the channel not to miss more videos about Packet Tracer, networking and Cisco courses. Hit the like button if this video helped you, and write in the comments if you have any questions about this exercise, about Packet Tracer, networking or Cisco courses. And I will see you on the next video. In this video I will demonstrate the laboratory exercise of the course Cybersecurity Essentials of Cisco. In this exercise we'll configure a wireless router, upload and download files using FTP, connect securely to a remote site using a VPN, and secure a Cisco IOS router. But before starting the demonstration, subscribe to the channel to see more videos about Packet Tracer, networking and Cisco courses. And if you like this video, hit the like button and write in the comments if you have any questions about this exercise, Packet Tracer or networking. In this demonstration I will talk in English, but if you want the version in Portuguese, check the links in the description. Se quiser ouvir a versão em português desta demonstração, veja os links que estão na descrição. Let's start doing the demonstration. First, you have to go to the Metropolis Bank headquarters network, and we are going to upload a file. So open the computer of Sally, and we'll connect to the FTP web server using FTP. So open the command prompt. First, let's test if you have connection with the FTP server. So the FTP server is this one with the IP 10.44.1.252. So let's try to ping the server. So write the command ping and the IP, and you have connection to the server. Now to establish a connection with FTP, write the command FTP and the IP of the server, so 10.44.1.252, and press enter. We have a connection to the FTP server. The username is Sally, so write Sally, and the password is FTP access, and we are logged in to the server. Now to upload a file, write the command put in the name of the file, that is secure.txt, and enter. Transfer complete, so the file was transferred with success. But the problem with this connection is because we are using the FTP protocol. This protocol is not encrypted, so all the access, all the communication was sent in plain text. So any sniffer on the network or during the communication until it reaches the server is not encrypted, so all the communication between the computer and the server is not encrypted, so this connection is not secure like this. And this is what you are going to solve on the next step. So you are going to configure a VPN client on the computer. Let's exit the FTP server, so right quit. Close the command prompt. First, we are going to check if you can reach the VPN server. So, the VPN server is this IP. Open the command prompt again. Write ping and the IP of the VPN server. So, 209.165.201.19. And enter. Let's wait. It's trying to connect. The first one failed. Let's wait again. Okay. The last ones worked. Let's try to ping again. So it's working right now. The problem was just the network was establishing the connection. So we have connection to the VPN server. Let's close the command prompt. Now open the VPN application. In here you are configuring the VPN. The group name will be VPN group. The key is 123. The host IP, server IP, is the IP of the VPN server. So 209.165.201.19. Now the username is Sally and the password is VPN Sally. And press connect. The VPN is connected. Press OK. Now we have a client IP because we have an encrypted tunnel between the Sally's computer and the server. So all the communication in this tunnel will be encrypted. Now let's download a file but with a VPN tunnel. We can close the application, but the VPN is still running. Now open command prompt. We are going to download the file from backups file. So this is the server, backups files server, and the IP. So let's try to ping the server. So write ping 10.44.2.10 and enter. Let's see if we have communication with that server. It's working. Let's try ping it again. So everything is fine. Now let's FTP the server to download the file. So write FTP in the IP of the server. So 10.44.2.10. Enter. We have connection to the server. The username is Sally and the password is secure Sally. Secure Sally and enter. You are logged in into the server. Let's try to download the file. So if we dir the server, we can see there is the file data.txt. To download the file, write the command get and the name of the file. So get data.txt and enter. Transfer complete. So the file was downloaded. The difference between this connection and the connection earlier is because now we are using the VPN. We are still using the protocol FTP, but because we are using a VPN tunnel, all the communication is encrypted. So all the access and communication is encrypted between the computer and the server. So we made the connection secured using an unencrypted protocol. We can close the Sally's computer. The next step is to configure the HQ wireless router. So this is the wireless IP. If you try to open, it is locked, so we can't access the graphical interface to configure. We need to remote access the wireless router. So open the field's computer that is connected to this part of the network. First, let's try to ping the HQ wireless to see if we have connection. HQ wireless, so this is the IP. Open the command prompt, try to ping, and the IP 10.44.0.254 and enter. We can ping the wireless router, so we have connection. Now, let's see, we have to open the web browser to access the configuration on the router. So close the command prompt, open the web browser on field's computer, and enter the IP of the HQ wireless router. So in the URL, write 10.44.0.254 and press go. It's asking for the authorization. Let's see. So the username is admin and the password is p@ssword. Press OK. We have access to the wireless router, and now let's do the configuration. Open the tab Wireless. Change the network name SSID from default to HQ Wi-Fi, and the SSID broadcast, choose Enable, so it can start broadcasting the SSID. Now go to the bottom, press Save Settings, and now open the option Wireless Security. The security mode, change to WPA2 Personal, maintain the encryption as AES, and the passphrase write Cisco 321. Go to the bottom, press Save Settings. Now the configuration is saved, and we have a wireless access point broadcasting the SSID using the security mode WPA2 with encryption and a password so users can connect to the network via wireless. Now the next step is to secure the HQ router. Let's close Phil's computer. The HQ router is this router. It's the gateway of the network. If you try to open, it's locked, so we can't access the graphical interface to configure the router. So open Phil's computer, that is in the same network. Let's try to ping the router to see if we have communication. So the HQ router is this one. We can see that we have two IPs for two interfaces, because you have an interface on the bottom and another interface here. We have two very different IPs because we are using two different networks on the same router. To see the names of the two interfaces, open the Options, Preferences, and on the Customize User Interface, you have the option Always Show Port Labels in Logical Workspaces. With it selected, now we can see the names of the ports. So the bottom one is Gigabit Ethernet 0/0. It's this one with this IP. And the other one is Gigabit Ethernet 0/1. It's this one. That is the interface. This part of the network is connected. Now let's secure the HQ router. So open Phil's computer. Open the command prompt. Let's try to ping the HQ router. So write ping 209.165.201.2, and we have connection to the router. Now let's connect to the router via SSH. So write the command SSH-L. Let's see the username. The username is Phil. So write Phil, and the IP for the interface is 209.165.201.2, and press enter. It asks for the password, and the password is secure SSH, and you are connected to the router. Now enter enable to have a special access. The password is Cisco. We now have privileges for configuration, and now we are going to activate the Cisco IOS configuration feature. Let's enter the global configuration mode with the command configure terminal and press enter. We're now on config mode, and first we are going to secure the boot image of the IOS with the command secure space boot dash image, and we get a message saying successfully secured running image, meaning that the iOS boot image is secured. Now let's secure the iOS configuration. Write the command secure space boot dash config and press enter, and you got a new message saying successfully secured config archive, meaning that the configuration of the iOS is secured. So both the boot image and the configuration file is secured. They cannot be changed or deleted by accident. Enter exit to exit the global configuration mode, and let's check the resilience configuration. Write the command show secure boot set and press enter, and we can see that iOS image resilience is activated, and the file .bin, that is the boot image of the Cisco IOS, is secured, and also the iOS configuration resilience is activated. The file .ar, that is the iOS configuration file, is always secured. Now we'll configure the banner MOTD, meaning Message of the Day, the message that shows when you enter the router, with the phrase Authorized Access Only. For that, you have to enter the global configuration mode with the command configure terminal, and in config mode, let's enter the command banner MOTD. I will execute the command, but this will give an error. The command is incomplete because it needs a special character, an hashtag, indicates where the phrase starts and ends. If we try again the command with banner MOTD hashtag and enter, we get a message saying that to end the message you need to write the hashtag again at the end. So every line between the first hashtag and the last hashtag will be the message. We only need to write Authorized Access Only, but we are writing something more. Let's write a few dashes, an enter, another enter, and now we write Authorized Access Only. Another enter, another enter, again a few dashes. All of this is the message. Another enter, another enter, and now we write get out. Enter, enter, and let's end with dashes. And to end the message, we write hashtag. That means the message ends here. And we press enter. And the command MOTD is complete. So the entire message we want to insert starts at the first hashtag and ends at the last hashtag. To see if we inserted the message with success, let's exit configuration mode and let's end the connection. Let's try again to connect to the router with SSH. We write the password, secure SSH, and enter. And now when we enter the router, we get the message of MOTD. In this case, all these dashes, authorized access only, so everyone that tries to access the router will get this message as a warning that they are not authorized to access this router. Now the router is done, we are going to connect Gina's computer to the wireless network. The computer of Gina is in this room. It's a laptop, doesn't have a physical connection to the router or a wireless connection to the router. So let's configure the computer. Open Gina's computer. Let's keep the computer in frame. Open the PC wireless application. Let's configure the wireless. So open the tab Connect, refresh to see the networks. We have the HQ Wi-Fi, that is this wireless AP we configured. Select HQ Wi-Fi and press Connect. The security is WPA2 and the pre-shared key is Cisco 321 and press Connect. As we can see, we establish a wireless connection between the laptop and the wireless AP. Now let's test if we have communication to the network. Let's try to ping the FTP web server. So open the command prompt and write ping, and the IP is 10.44.1.252 and try to ping it. Request timeout. Okay, now it's working. Let's try again. So we can communicate on the network. Finally, we'll verify if Gina's laptop uses DHCP. So on the computer, open the IP configuration, and we can see that the IP configuration is using DHCP. So when we connected to the network, we got automatic configuration. We got an IPv4, we got a subnet mask, the IP for the default gateway, and the IP for the DNS server. So all the configuration we need to communicate on this network. So this was everything we need to do for this exercise. So now subscribe to the channel if you want to see more videos about packet tracer, networking and Cisco courses. Hit the like button if this video helped you and write in the comments if you have any questions about this exercise, about Packet Tracer, networking or Cisco courses. But especially write about your thoughts about this course and if you are thinking to do the next level course from Cisco Cybersecurity. Thanks, and I will see you on the next video or the next course.